Hi, my name is Sean Batum, and today in this podcast, I'm going to be discussing momentum. With the help of a friend, I'll explain what momentum is, how it works, and what variables have an effect on it. Now, to help me better explain and demonstrate, I'm going to pass this on over to expert artilleryman Sergeant Bighorn.
How you doing? Sergeant Bighorn here, U.S. Marine Corps. Now here's the deal. I got an enemy stronghold over there, and I got Charlie all over the place. Now my CO wants me to take it out, but he's only giving me one round to do it. So I need to figure out which one of these puppies is going to carry enough momentum to take her down, and I'm going to use physics to do it. Alright, Candy Cane, listen up. Now momentum is inertia in motion, okay? Now the law of inertia states that every object continues in its state of rest or of uniform speed in a straight line unless acted upon by a non-zero force, okay? Now momentum is also defined as the product of mass and velocity. Now if you increase either one of these, you will in turn increase your momentum, okay? Now for you non-intellectual types, basically what I'm saying is getting hit by a tank at 45 miles an hour is going to hurt a heck of a lot more than getting hit by a raisin at that same speed. Now this has to do with us because it also explains why this projectile should do a lot more damage than this projectile based on the fact that this has a lot more mass, in turn carrying more inertia or momentum. Okay, now, these two projectiles are the exact same size, but this one weighs about 4 times as much as this one. We're going to be firing both from the same catapult, with the same firing angle and the same amount of force. So when these puppies leave this bad boy, they're both going to have the same acceleration. And their momentum is going to be left completely up to their individual mass, okay? Now, when we load this puppy, we put the ball in there, and when we pull it back, we're going to be storing a hell of a lot of potential energy in these here bungee cords, okay? Now, when we pull it back and we release, that potential energy is then going to be converted into kinetic energy, ultimately firing our projectile into the hearts of the enemy. Alright, Cupcake, listen up. Here we are on location. Now over there we have the enemy stronghold. And if my theory is correct, the heavier ball should carry more momentum, in turn doing more damage to the enemy. Let's see what happens. Ready. Aim. Fire. Beautiful. Okay, now for the sake of getting a thorough explanation, and because I just really like to shoot stuff, I'm going to fire the less massive round at a very similar target and see what happens. Here we go. As you can see, nothing happened. Now, because I don't believe in leaving intact targets around here, we're going to fire the heavier round. Yeah.